Our next speaker, Dr. Howard Shapiro, may disagree with this statement, but I describe him as the greatest mind in agriculture and agroforestry, if only because this is the GoldLab Symposium, and that's the standard for today, but also because of his lifetime of work in plant genetics, in the study of plants, and the study of our food industry. He's also a fellow at the University of California at Davis in the College of Agriculture and Environmental Sciences, and a scientific advisor to the Mars Corporation and also to the MIT laboratory. But how does someone become the very best in their field? Well, the simple answer is time and very steady hands. At the age of 5, Dr. Shapiro began his career hand-pollinating plants at the New York Botanical Gardens. So it's for that 5-year-old Dr. Shapiro that I'm humbled to introduce his talk that will deal with the issue of childhood malnutrition and the impact of stunting.
Well, you always have to have at least one plant scientist in a meeting like this. So I'll be that token plant scientist. I'm very honored to be here. Thank you so much. I want to thank Meredith for dogging me for a year to actually make these arrangements. So I'm very pleased to be here. I'm kind of the Grim Reaper post-lunch. I don't really have any other jokes. That's it. And I'm going to talk about a couple of things. I'd like to start by sharing with you some information about the state of agriculture in the world. It's really not bright. I'm encouraged by much of what you all talked about human health. But the idea of agriculture being a sustainable system at this point is pretty far-fetched. And chronic hunger and malnutrition is something that really impacts people in a way that is almost inconceivable. And I'll close with this little story about aflatoxin, which only impacts 4.5 billion people a year, which is pretty much more than all the chronic diseases put together. And we haven't made any headway on that. We haven't made any headway really on ending chronic hunger and malnutrition, but a few statistics first. I should be able to make this work.
Can you turn up the volume? So the mic's up as much as it goes right now. Are you okay using a handle?
Sure. I think it's the beard muffling it. No worries. Okay. So the status quo. This is kind of what the world looks like in a normative sense, if you will. There's cities and there's slums. There's 30 tractors growing across a big field in the Great Plains. There's maize that has been infected with mycotoxins. There's erosion. And then there's planes spraying chemicals across fields in order to kill off particular bugs that might attack it. But humans and nature have a funny relationship, as you know. There is the ability to live with it. We can live with nature, but we tend to tame it and cultivate it, and then we conquer it, and then we exploit it, and then we have the ability to change it. And I've been very fortunate to be able to see an entire track of information to be able to really work in a way that I never thought I was going to be able to work when I was a young person. And at 5 years old, in the early 50s, it was not called child labor, it was called an experience. So there's 7.4 billion consumers in the world. There's 1.5 billion producers in the world that grow what we eat all around the world. And here's a frightening thought. There's only 300 to 500 companies that essentially process almost everything that you eat and deliver it to your household table. This is a footprint of an American that equals 43 Africans. So when you think about footprint and you think about Africa going to be the most populous continent by 2050, there's something that's going to happen that we haven't taken any consideration for in any way, shape. And food production is actually the biggest threat to the planet. And I'll explain that why as we go on. This gives you an idea of some of the basic statistics. Whether it's biodiversity or freshwater or greenhouse gases or marine stocks or the most chemical use or 50% of the topsoil loss, agriculture is responsible for all of this. And it's not to say there isn't a system of agriculture that's extraordinary and is regenerative and allows us to live on the land and have a relationship with that land that is quite profound. But this is 95% of what we have to have in order to feed the world currently. And the theory has always been reward the best. But is it really the idea is rewarding the best is the most sensible? Or is it to move the worst to being average that will actually cause much less damage, much less use of water, much less use of agricultural chemistry? And then we can start to have a system that becomes robust. A quadrillion, 1.5 quadrillion kilocalories are lost through waste, and because there wasn't stored properly, and because it had aflatoxin, and because it was linked with E. coli or salmonella. It's a gigantic amount of food. It's almost incomprehensible when you think 1.5 quadrillion, quadrillion kilocalories are lost every year. And a lot of it's lost in the industrialized areas of Asia, but in North America, we have our fair share as well. And it only is embedded with 1.3 billion tons of food waste, which represents 45 trillion gallons of water. I live in California where we have a shortage. This would more than cover California for many, many years. 24% of all the water in the world is used for agriculture. They're not making any more land, and they're really not making any more water at this point. We're a closed system. And if you want to study a little bit of politics as well as food, this particular chart illustrates food riots over the last series of years, almost 10 years. And if you look at that chart carefully, you'll see the Arab Spring, you'll see problems in Africa, in the sub-Saharan area, and other parts of the world, all related to food riots. And most of these riots were created by a single problem. In the case of Egypt, it was wheat. But where did the wheat fail? It didn't fail in Egypt, it failed in the Ukraine. So the impact of the Ukraine actually had a very, very major factor in creating what was later be known as the Arab Spring. Just one failure of one crop. So reality. Well, globally, we're going to increase incomes, which means we can afford more meat products, more animal protein. You can see that in the fact that the amount of protein that China is now buying versus 20 years ago, the fact they own one of the largest pork production facilities in the world. They import pork, they import beef, they import chicken, they import fish. And that's going to happen in other places as well in an increasing level. So arable land is declining due to erosion. Access to water is declining because we've pumped the aquifers almost dry in many places. When you think about the Ogallala Aquifer, one of the greatest stores of water in the world, nobody knows how much is left. No one can even predict it. So when it's going to run dry, it's just going to happen one day and everybody's going to say, turn the taps off. The bottom line is the poorest people on earth can spend 75% of their income and still be hungry, which is pretty shocking. And I was listening earlier today to the presentation about Medicaid and Medicare, And you realize that we actually have a pretty good system because it has some protection in it, even though the current administration is trying to eradicate most of that. So there's 7.4 billion food experts in the world. Every one of you is a food expert. Social media currently trumps science, especially about agriculture and the nature of genetic engineering or GMOs or gene editing or any other modern technology. Extremes dominate the discussions. Traceability and transparency are something we're just starting to understand in our food supply chain. And there's a great distrust between trade globalization and experts. I work for a large food company, Mars Incorporated. We've done 150 peer-reviewed studies on the efficacious dosing of flavanols, flavanthriols, and flavonoids. And still, there are people who will say it was supported by an industry, so therefore it can't be trusted. So we have a situation where private industry is stepping up as well to provide most of the money these days to land-grant universities to do most of the research. So someplace we're going to have to come together on that conversation as well. And Feynman, when he wrote about the Challenger disaster, he talked about playing Russian roulette. Success in the last round is not a good predicator of success this time. And nevertheless, people unconsciously adjust their definitions of acceptable risk. So agriculture is an acceptable risk. You go out and plant some seeds in the ground, you pray the weather is right, you pray it doesn't get too cold in the wrong time. The harvest comes, no pest, disease, fungal pathogen shows up. The entire time most farmers are farming, I think prayer is their best solution as they go to the bank. And they try to explain to a banker why they should be lending more money, and it's a very, very cryptic system. So Russian roulette is not a good way to think about any of this stuff. And the speed of change is faster than our response. And I heard that from a number of people who spoke yesterday and today, specifically about how we make a discovery, we think we can change, and the response time is nowhere near as fast as it should be. And whether this chart reflects pharmaceutical discovery, translation, and scale, it also reflects largely what happens in agriculture and other environmental crops. So I'll ask, does anyone here know what that seed is? Oh, come on, it's 1/600th of a gram. Golden rice. That would be good, but it's not. That's 2 days, 1/600th of a gram. This is 2 months. And this is 2,000 years. This is General Sherman, a giant redwood in California. Weighs as much as 6747 airplanes, and no one has ever figured out how water gets to the top of the tree. The hydraulic system is really undiscoverable at this point. 1/600th of a gram contains all that information that's allowed this tree to grow for 2,000 years. So I'm a seed guy. I really appreciate seed. It's a big part of my life. And these 4 people I've had intersections with over my life. And I thought I would talk about them in the context of what I'm really going to speak about today. Frederick Sanger, he won the Nobel Prize for Chemistry twice, one of the rare people. Gerda Kusch won the World Food Prize. Barbara McClintock, of course, transposons, won the Nobel Prize for Physiology or Medicine. And Norman Borlaug, because there is no Nobel Prize for Agriculture, won it for peace, and justifiably so. Frederick Sanger, someone spoke earlier today, I believe, about working in the Sanger lab. I only met him one time, but imagine what it was to invent a sequencer in his laboratory. It's such an amazing thing. We opened the world to ourselves. And in that box is a high-seq Illumina sequencer, which was given to us by Illumina to put in our laboratory in Africa, where we have established the most advanced molecular biology sequencing facility for all of Africa. But what does it really mean? Because at one point, all of us who work in the agriculture in the fields would walk out in the fields with a notebook like Borlaug, take notes on every plant we would see. We would walk rows and rows and rows. We would grade those plants 3, 5, 7, and 9, 9 being what you really want, 3 being the low end of the characteristics that you hope were carried through in the breeding program. Then you would collect those ears of corn to what we could do now, if I can get this video to work. That's what we used to see, some kernels of corn. And that's the genome where all the information is. Single endosperm cell, condensed chromosomes, scaffolds, histones, and DNA. So imagine in a lifetime, I mean, flying an airplane doesn't seem as advanced as this to me, to go from walking a field and counting ears to looking at a plant this way has really changed everything we do. When someone says, what has been an intervention in agriculture that really stands out? So imagine starting with teosinte, where the seed is on the outside of the plant, and moving it all the way to 16 rows of perfect lined up seed on a modern corn. Genetic engineering could never have done that. This is an explosion of information. And when someone complains about genetic engineering, I just laugh, because humans did this. Humans did this entire activity of changing teosinte into modern corn. Human hunger and desires are elastic. This is Gerd of Kush talking. And Gerd of Kush won the World Food Prize for feeding more people with a certain variety of rice than anyone else has ever done in history. I mean, all of Asia eats his rice. And here's an illustration of what it takes to have done that. This is the breeding diagram that gave us IR64, which is the most eaten rice in the world, or bred with other rice, new varieties, produce IR64 clones or children or progeny in the future. But imagine that this was the thought process when Gerd did this, compared to what we could do today using sequencing and other technologies to be able to get to the same thing. I look at this, there's China, Indonesia rice, Philippines, Korea, Thailand, India again. That's on that parent line. Over here it's Philippines, USA, Philippines, Blue Rose, India, China, India, Thailand, and then IR64. It's miraculous that one person could actually figure this out. It really is. It's genius. So he won it for feeding people. So the title of the presentation is about uncommon collaborations, because nothing that we used to do in the world that I live in can be done the same way as it was done 30 years ago, when you would work your field by yourself, or you would have 1 or 2 colleagues. And Theobroma cacao, the food of the gods, named by Linnaeus. He named everything after himself, Theobroma cacao Linnaeus. It's a pretty good gig if you can get it. The yield on this crop is the same from about 1850 to 2018, 400 kilos per hectare. It's a poverty crop. There's no way you can talk about it any other way. So I had this idea, I'll sequence this, and this will be the big moment in my career. It actually made the under the fold in the New York Times when I announced it. I'm sure my mother in heaven would have appreciated if it had been above the fold, but. So in 2010, we had decoded it. This is the double helix dipped in chocolate. And this was the group that did it. because it's very hard to have all the capabilities as science moves as fast as it's moving today to do this just by yourself. IBM, because they have computational capabilities that almost nobody else at that time in the world had. This is pre-Google setting themselves up. USDA-ARS had access to germplasm that no one else had because of rules and regulations. Mars had the money. I was able to pay everyone to do this work. Hudson Alpha Institute, phenomenal capability on assembly of genomes. They came out of the old Redstone Arsenal programs. The rest you can read. When I asked for the money for this, I was given the money. I asked for the time. I said 5 years, because that's what a genome was taking at this point. And John Mars wittily said, I'll give you 2 years. Get it done in 2 years. Make it worthwhile to the people who need it the most, which are the African farmers, the Asian farmers, and the South American farmers. So we did it in 2 years, 2 months, and 10 days. So Norman won the Nobel Prize, and I had a lot of relationship with him in the early days when he was at CIMMYT in Mexico. I was a young plant breeder in the Oaxaca Valley, working on land races of maize. All the maize in the world comes from Oaxaca. It's the origin of the crop. And he was a very ornery character, and we argued a lot. But he won the prize because the governments of India and Pakistan said we have rice that grows very tall, and when the winds come and the rain comes, it knocks it over, and that's called lodging in my world. Can you give us something that is dwarfed that won't fall over in the rain and in the wind? So he and a man named Swaminathan, M.S. Swaminathan, bred a dwarf wheat and solved a problem, kept 200 million people from starving. It's in the same category of Kurdish Kush when he won the World Food Prize. And that's one of the reasons the World Food Prize was established by Borlaug, because there wasn't a real prize for agriculture in the Nobel system. So Norman was ornery, but he said you should always do what you can do as fast as you can do it to solve as many problems, and you'll make mistakes along the way, but people will remember your successes more than your failures. 37, 48, and 7. Anybody have any idea what that algorithmic numbers are all about? 37% of the children in sub-Saharan Africa in the rural sector under 5 are stunted. 37%. 48% of the children in rural India under 5 are stunted. 7% of the children under 5 in the United States are stunted. Stunting's forever. You can't get a pill and take it and get better. When you're stunted for life. And I'm going to explain this because this launched an activity. Actually, I have a full-time job, and this became something that I realized that as an individual working in agriculture, I had to do something besides breed cacao, breed peanuts. I led the peanut genome as well, and other crops that Mars uses. So stunting is caused by chronic hunger and malnutrition. It's physical. What you normally see when you talk about stunting are people measured for their height. But I want to tell you it's neurological too. So there's an issue where your body, your mind does not develop, the neural tubes do not develop appropriately. And economically, you're never going to make the money that you would have made if you had had everything going for you. And you'll be severely impacted by diseases, and you'll die young or younger. I heard a 5-minute lecture by a young professor at UC Davis, Christine Stewart. She told this story about stunting. All the statistics were there. I couldn't believe what she told me. Actually, I just said to myself, I can't believe this. How come I don't know about this? How many of you in this room knew about stunting or know about stunting in a serious way? Okay, that's 5, 6. Most of the time, no one raises their hand because it's not something we think about. And you can see the countries in red on this slide where stunting occurs, and it's a lot in Africa, and it's a lot in India, and 7% in the United States. So I hate stunting. It just pisses me off. It really does. It makes me so mad that we could have something like this existing in society. So when we ship huge boatloads of maize or wheat over to Africa, does anyone ever say, I wonder what the nutritional level of that stuff is? Does anyone ever say, is it going to meet any of the needs they have in order to protect them from chronic hunger and malnutrition? And the answer is no. So Nature in March published a paper about mapping the child growth failure in Africa. It's horrific. And most docs don't talk about it either. So I decided I would chart out what would have to happen. This is only half the chart. If one were to try to fix Africa, you can't fix everywhere. Somebody else will fix India. But I've worked in Africa for decades, and I just started writing this out about all the details I would have to do to get something like this done. And of course, it's preposterous, because I didn't have anybody to endorse it, including most of the World Health Organizations. I didn't have anyone who really took it as seriously as I thought I was taking it. I didn't have any collaborators. But all you got to do is keep thinking about it. Now, everybody knows what this is, right? Because you eat broccoli all the time. You eat vegetables like this. You know they're full of folates. We talk about it all the time. But they're so critical for neural tube development. So when we talk about development, I'm not talking about a baby being born. I'm talking about a young woman 2 years before she's pregnant in Africa getting the right diet. Because the 1,000-day program, as good as it sounds, is absolutely wrong. It's not for the pregnancy in the first 2 years. It's 2 years before that you have to start. So simple things like folate. Everyone knows what this is. But what do you get out of greens like that? Hemoglobin is enriched by it. And that's normal right there. That's what you want to have in your body. And that's what you have in most African mothers who are pregnant. Iodine stops cretinism. None of the plants that we send over for food surplus have any of this stuff in it. Simple nuts. Zinc to stop stunted growth. Vitamin A. There's your normal vision at night. That's what you and I see. That's what night blindness looks like. It's pretty profound. Almost nothing we eat every day has been improved nutritionally. Almost nothing you had at lunch today has been improved nutritionally, because yield was the driving factor. Higher yield, smaller space, more profit. I understand that completely, and I don't object to it. What I object to is the seed companies, all the giants, have never worked on nutrition. They've worked on yield, pest and disease resistance, all good. But the fact is, no one has worked on nutrition in a plant for about 50 years. It's a mess. So this was the vision in 2012. What we're going to do is we're going to figure out what the basic or most important food crops are pan-Africa. Then we're going to improve them nutritionally, every one of them. And we're going to sequence them so we have a body of information of reference genomes, and then we're going to resequence each one 100 to 150 times so we actually have a way to read an encyclopedia of information to improve the nutritional system of Africa. Now, that's a pretty crazy idea. But I ended up getting some great partners to do this. And I was telling Meredith, if you don't have a cartoon in your lifetime made about yourself, I'm not sure you succeeded. So this is Nature. This is Nature magazine from this cartoon recently.
The beautiful baobab tree, or tree of life, is an African icon. The baobab fruit contains 4 times the potassium of banana, 3 times the vitamin C of an orange, and twice the calcium of spinach. But the baobab is an orphan. Science has paid little attention to this tree, until now. The African Orphan Crops Consortium is harnessing the power of genetics for orphan crops. The baobab tree is the first of 101 plants to have its genome sequenced, assembled, and annotated, and the information will be made available to all, unrestricted. Where millions of people are malnourished, this genetic data will help farmers provide the food they need. The genomes will guide African plant breeders so they can create crops that are higher yielding, water and nutrient use efficient, resilient to climate change, and full of nutrition, triggering a huge leap forward for the diversity and sustainability of the continent's agriculture.
So that explains essentially what we're doing. So we sent out 100 surveys and got 106 surveys back from Africa, which is pretty good for a survey. They chose about 200 plants. We did the statistics on it. We ended up with a list of 150. Then I had to find someone who would sequence them all for me. And on Thanksgiving in 2013, I was at BGI, the Beijing Genomic Institute, meeting with Jian Wang and Jun Jun. And we had this conversation. I said, in my lifetime, I'd like to do 12 plants. Because it's a big deal. People do one crop and they feel like they've been successful. And Dr. Wang said, no, that's insufficient. You won't make any impact. I said, we'll do 24. It's insufficient. Then it got up to 48, and we ended up with 96, and he rounded it off to 100. And they said, we'll do 101 genomes for you for the cost of the reagents. We'll throw in everything else. And what's next? I better have a lab somewhere to extract all the DNA so I can send it to China. But maybe I would get an organization that supports us. So this 100 crops were chosen. I went to the African Union President's Council meeting and proposed this. They accepted it. And I'm walking out the door and someone said, well, you forgot one crop, which is pretty astonishing to say. We're going to do all this. You forgot baobab, which is the icon of Africa, which the leaves can be eaten when there's drought, there's always leaves on these trees. So we're doing 101 crops. And then I realized, well, who's going to use all this information? So we started the African Plant Breeding Academy, where every year we train 35 people. We pay all their expenses. They come 3 times a year for 2 weeks. We have the best teachers in the world, led by Rita Mumm, the great geneticist from the University of Illinois, Bruce Walsh, who wrote the book on computational genetics, Yago Hale, who is a specialist in R, so we teach in R, and then Alan Van Dynes, who's a great guy in the field. So every cost is paid. They leave their house, they jump in a taxi, they fly to Nairobi, where we teach. They're housed, they're fed, they're taught, they're flown home 3 times in a year, and they graduate after that. And actually, I'm leaving from here to go directly to Nairobi. This is the last week of the class, and they're graduating next Friday. The point is that without the plant breeders who are trained to use this information, you don't have anything. And many of these people have their PhDs 20 years ago when this information was not available to work this way. So we train everyone. These are the families of which the plants are involved with. And you can see, and most of you who know plants, the big ones are the ones that we've chosen from. They're the obvious ones. Bambara bean is the best source for protein in East Africa, and spider plant is the best source for folates, Pan-Africa, and cocoa yam is from West Africa. So the plants and the students are chosen from across the entire continent. And I'm a little embarrassed to talk about petaflops when Patty talked about yodaflops yesterday. This is pretty small potatoes compared to what she talked about. So each one of the genomes will be resequenced after we have the reference genomes. It's all in the public domain, held under the auspices of the African Union, so everyone can have access to it. It's held by Google Genomics in their cloud. It's hundreds of thousands of dollars to put something in the cloud for storage for a long time. Google is one of our partners, and this is class 1 graduating. And much like at the academies when they toss their hats into the air, this is the African Plant Breeding Academy, which you only get if you've successfully completed the class. Now, some people come from very poor institutions, and when they do come from those places, they have really archaic computers, so we give them a new computer on top of everything else. This is class 2 graduation. The formality was something I wasn't really ready for. And this is class 3, which will graduate this week. 18 women and 17 men, which is quite unusual in Africa to have half and half, men and women. And this is what an uncommon collaboration looks like. None of these groups had ever collaborated with each other before. And it's not that you can't make a discovery and execute it and translate it to scale on your own, but this is how you have to do it in Africa. These are the kind of players you have to bring together to get it done. And here's one of my favorite people in the world, Barbara McClintock. And I think what I have the quotes from her here, I never thought of stopping. I just hated sleeping. I can't imagine having a better life. She's talking about herself as a scientist. And she inspired me in a different way, because this microscope and those ears of corn was all it took to win the Nobel Prize. It's pretty profound, the discoveries she made. She wasn't treated well by the male scientific community. And I encourage you to read her Nobel speech sometimes. It's rather interesting. Someone said to me after we got going on it, "You forgot aflatoxin, Howard. What are you going to do about aflatoxin? Because it impacts so many grains, so many spices, so many crops, including cacao." So I really hadn't thought about it. So I said, okay, it's only a class 1 carcinogen. 4.5 billion people eat it every year, causes liver cancer, causes kwashiorkor, and causes stunting. Okay, back to stunting. How are we going to fix this? So my thought was I would fix it in storage, and then I would fix it in plants. So we're working on it in storage right now, as you'll see. And then with plants, we're using gene editing and early stage Cas9, but it's really like Cas12 or 13. We're not in the first generation any longer to do that. So time for action. You got a problem? Let's use public science to figure it out. Let's make a game out of it. Enfolded is an online game for scientific problems. So on the World Food Day in 2017, which was before Thanksgiving, we launched the Folded Puzzle for Science for Aflatoxin. I'll give you an idea who plays this game: retired people, professional scientists, mining and quarrying engineers, which surprised me, management of companies, healthcare, finance and insurance, and construction workers. Turns out I know quite a few truckers who play this now that I started this. And the age group, large group, is from their late 30s to the 45. So we launched this puzzle. This was the launch in California. This story has been seen by 200 million people around the world. This is what we're going to do. We're going to have an enzyme redesigned to degrade aflatoxin. This is basically what it is. This is what playing the game looks like. So when you go online tonight, the best player in the world is Susan, a housewife from Atlanta, Georgia, with 3 children. She's a genius at this. So we're folding proteins. 460,000 people play this game. We've had the first puzzle. It's now in our hands. Out of the 300,000 puzzles that were solved, 100 look like they may work. They're over in Germany at Thermo Fisher, who's a partner. Again, an uncommon collaboration, because I'm not sure I could afford everything we're doing if I was trying to fix aflatoxin with my Mars budgets, so we went out to the public. And in closing, this is in Australia for the Aussies in the room. I mean, there's an emergency 174 kilometers ahead. Well, the truth is the emergency for the food system is right now. The emergency on aflatoxin is right now. And I think we have a chance to solve it in the methodologies that I've rushed through to tell you all about. So we don't have much more time, but someone said, well, what do you do in your spare time? And of course, spare time is rare, but this is what I do. I have a company called Double Helix Racing. We're a racing team. We go to the Bonneville Salt Flats every year, and we have exceeded over 200 miles an hour on this bike, and we're going back this year to try to hit 240 with some modifications. So this is what gene jockeys do in their spare time. Questions?
Thank you. All right, we'll start taking some questions.
I don't understand what having DNA sequence has to do. I don't understand what having DNA sequence, the genome of a plant, has to do with improving its nutritional value. It could be decades between having the sequence and changing the nutritional value of a plant.
Well, having the genome gives us a roadmap to know where to look for plants that we have measured that have higher nutrition. But in a breeding program, it could take as long as Gerd of Kusch's picture. But having a genome and knowing on which chromosomes what we think is an improved nutrition from the analysis of those crops, it allows us to make a decision on a breeding program for a plant this big. All I need is 2 true leaves, and I can determine if my crosses were accurate. Gerdif had to wait 120 days between his sequences of growing crops. So it's a matter of speed. It gives me information that I wouldn't have otherwise.
How about you were hesitating, but you know you want to ask.
So in growing plants, we use a lot of fungicides. So, and when you do that, you kill a lot of species. And what in microbial ecology, the interspecies competition is often what keeps one pathogen from producing too much of a toxin. Or many of the other species will actually degrade that toxin. So is it possible that with the way we grow a lot of our grain crops now and the use of fungicides is depleting the diversity of the fungi in the soil and around the plants, and that's contributing to an increase in aflatoxin?
I don't think that increases aflatoxin. Weather stress is one of the biggest reasons. Aflatoxin's everywhere. We walked out into this courtyard and dug up some dirt from where these trees are growing, you'd find aflatoxin. So it's everywhere. The thing that you alluded to, I think, which is more important, is the microbiome of the soil, which almost no one has been able to articulate fully. And the truth of the matter is farmers spray very little fungicide because it costs them a lot of money. And they're breeding plants that are more resistant to pest and disease. So there's a balance there. But the aflatoxin is caused by stress. And, the goal on the aflatoxin, aflatoxin knocks on the door of the plant today. Plant opens the door, says, come right in. So we think we can breed a plant that when aflatoxin knocks on the door, it can't come in.
One last question.
I just wondered, in the complexity of Africa being a big continent with many countries, this seems like buy-in from all the countries. So how much do you have to deal with politics with all of this?
I don't deal with any of the politics. This program is approved by the President's Council of the African Union, which represented all of Africa. So the mandate to do the program, the ability to move DNA to Shenzhen, China, to BGI, or actually to Hong Kong, where they have their big sequencing facility, makes it possible to get this done. We have the ability to move germplasm inter-Africa underneath this protocol. And they own the IP. There's no IP that anyone can possibly own except the African continent.
All right, let's thank Dr. Shapiro for that talk. Matt?